Hello everyone again to my YouTube channel. Hello the learners. So I will still continue in this project of the house prediction based on the feature provided. Well, in the two last sessions I discussed feature engineering and also I discussed exploratory data analysis because two phases necessary in any life cycle of project of data science. So today in this session I will show you the feature selection, okay, of advanced house price prediction. Well, I will just today in this session show you some tricks how we can use in or select the features. So as I know or as we know before, we discussed in this topic. So we can now use any feature provided. That means if we working to solve some project, at this time we can face in a lot of feature side of this data when we have when apply this process of gathering the data. At this time, we can face a lot of features. That means you cannot use any features provided inside on this data. Maybe some features can be noise our model when we predict uh, the target. Well, in this session, I will just show you some tricks that we can use to make this feature selection. Well, I shared with you before this link of data, source of data. It's Kaggle. So Kaggle is one of the famous platform of data science in the world. It's a forum of data scientists in the world. So this website give you the ability to build in your own notebook for some project. That means to contribute or to download or to upload. Sorry, the data if you can download the data, your own data, or you can also build in your notebook as I tell you before, share it with other. The other give you the tips, give you the advice. Okay. So will in this session I will use some basics packages in Python. Well, we use in the pandas to read the data. We have NumPy to make some manipulation, Matplotlib for visualization. We have also a scalar for machine learning. So in this time we are selecting the linear model because the price prediction or the house price prediction is a regression problem, regression analysis problem. Okay, we have a lot of advanced techniques to do that because in the real project we have a lot of things to do before trying to making or to building a model. We have the techniques that we can use. We can use, for example, um, that's what's called TSNA. We have also LDA. We have I remember it. Sorry. Okay, we have this technique of clustering. I remember the exact name. Okay, it's okay. We call it yeah, component analysis. Okay, component analysis. That means if we have high level of dimensions, that means we can reduce this dimension. Okay, but we have the SNA. That means we give for this technique any dimension we want of the data and we return it as a result into dimension. It's very important technique. And we have also some self-organizing mapping. Also, is advanced technique. About for this session, okay, I will build in the tutorial for this session. Okay, in the for sorry, I will build in the tutorial for these techniques in the next session. Okay, in the future. But just I will show you. We have a lot of things to do before trying to making this model prediction. The last thing we can do is the linear model, or if in case of classification, for example, okay, we can apply some algorithms like for random forest or whatever, okay, in or whatever, or non-work. But before that, as I tell you before, we need firstly understand the data deeply, and to understand that we need to apply this technique of principal component of the SNA of LDA of or some okay some technique. Some does mean self-organizing mapping, as I said before. Well, in this session, we want just to import in some basic models is lasso model. Well, if you remember all, the lasso model is is so inside of this equation of regression, as I told you before, we have one part of hyperparameter. This part of hyperparameter help us to making the selection of features. Anyone interested to know that the play, we can return to my playlist of linear regression. I explained that the play theoretically. Okay, I explained the math behind this linear model or lasso or ridge. Well, in this case, it's lasso. That mean we need to penalt these features. We need just show or a choice some features. There is no ability to choose all the features here. That's what I can assure you now. Well, we have in the syntax pd.pandas set option display max color. That means we need to apply the max possible of columns. Well, we are still working in this extreme CSV. We're using this dataset pd.read CSV function because we have C, CSV format for this, and we applied this function of heat to show just 5 top record. After that, we need to separate the target variable, and how we can do that, we can create in another variable called y. For example, in this case, we have white rain equal to dataset. That means we need to choose just target one. There is in this case is sales price. Okay, we selecting this sales price and we store it in our variable called white rain. Okay, if we still continue here, we need to drop the independent or dependent feature. That means the target. How that can create in another variable called extra, for example, equal to data set to drop ed and sales price access equal to 1 because we want to drop those columns. So for ID, there is no information to extracting from this column. That means we need to drop it because that's coming a noise feature. And in this second part, we have sales price. That means we have this target variable. We need to drop it and make it in another separate variable. Okay. Here, if we are looking these tips or this observation we have here, we have apply feature selection. First thing or first step we do here is to specify the least regression model and select a suitable alpha equivalent of penalty. That means, as I told you before in this equation, we have a parameter called alpha. If we give or if we assign a high values for this alpha, that means we need just selecting some features. There is no ability to choose in all. And the bigger the alpha, the less feature that will be selected. That means if we give a high value for this alpha, that means we need just or we can choose just a few features. Okay, if we give, for example, zero point 0.9 for alpha, that means we can choose in just few features. But if we go or if we assign values for this alpha, for example, 0.001, at this time we have the ability or we have high probability to choosing a lot of feature. We will select the feature with which coefficient are non-zero. Well, so if we look in this case, we have feature selecting cell model equal to select from model. Select from model is we associate from this one. If from scalar dot feature selection import from model. That means okay, we apply this function of select from model based on the feature selection here provided by select or scalar package. So in this case, we have select from model. We have lasso because we importing the lasso, the linear regression, of course. And for alpha, as a programming, we give it some value of 0.005 and random state equal to 0 because we want just to run it one time. Remember to set seed random okay features. The random state is this function. Okay, remember to set the state. The random state is in this function. Okay. Well, so for random state, we give it 0. We can give it any number we want. Well, for feature selection model, we fit this extreme and prime. Okay, we fit it. We okay, and if we look in this parameter, we have this for selection model. We have estimation is a lasso for with these values, and copies is 0, first insert is 0, max iteration is 1000, normalize fails, positive, false. We can change all these values. For example, here positive, we can give it true, not false. Okay, random, so we can give it any value we want. Here we feature select. That means we are choosing just the feature we want. Feature cell model dot get support. So this support also checking the value inside of this feature selection how it is. This is true or false. It's a Boolean test. Okay, it's easy to understand. Well, let's print the number of all unselected feature. So in this, how we can make a list of the selected features. Selected feature equal to external dot columns. Okay, we want just the columns here for feature selection dot get support. That means it's we applied filter here inside of this column function because we want just the feature select model. We don't want all the we don't want all the features. We want just the selected ones. Well, let's print some states. Here we have data features, format external dot shape one because we want just the number of columns. We have 82 of features. And we printing now print selected feature. That means we print just the selected ones. We have formally selected feet, and this is 21. Print feature with coefficient frame to 0, format to SMP or SNA plus same of select dot estimated coefficient equal to 0. There is 61 features. That means those features it's shrinking to 0 is very close to 0. Okay. Well, this is the selected feature, the name of the selected feature here, as we see. We have Medina neighborhood over call, so what? Okay, we have garbage finish, garage car, paved drive. Okay, there is some features here. So, and if we look in here, we're assigning again this new feature or this new variable called extreme equal to extreme selected speech. Okay, that means inside of this we apply this filter. And we have extreme dot heat. This is the value we have here in the end. Okay. So it's a quick process here because we can do a lot of things. We can do something more than that, but just I give you for this purpose of education, I give you just the steps, okay, the first steps, and I give you a big picture of how does work, okay, and all the phases we need to building a life cycle project in data science. Well, I hope that's clear for you. See you again. Bye bye.